Now welcome to the classroom. Last time in our last video we spoke about the stages of the mid-latitude cyclone, spoke about the initial stage, the wave stage and the mature stage, and we left out this stage, the occlusion stage. Importantly, what we need to understand is how does this stage occur. Our occlusion stage occurs right after the mature stage, and it occurs when the cold front start to catch up with the warm front. The key term that is important for you to understand there and to remember, it catches up with the warm front. The cold front catches up with the warm front. Now, why does the cold front catches up with the warm front? What is happening? It is because the cold front, since it is the leading edge of cold air. Now, our cold air moves faster than the warm air. As a result, this will push the cold front to move more faster than the warm front. And eventually what's going to happen, it is going to catch up with the warm front. Cold air moves faster because it has more molecules that are closely packed together, therefore giving it more mass, and as a result, it is able to push through the atmosphere. Hence, our cold air moves faster than the warm air. Now, suppose that we are supposed to identify the stage of a mid-latitude cyclone that is depicted on a diagram. Remember, this is how it is more likely to be represented on a synoptic weather map. And you should not confuse this stage with the mature stage. We said in our last video that the mature stage forms a clear V shape. The warm sector forms a clear V shape between the fronts. But now when you look at the occlusion stage, the shape of this system forms a more like of an obscured Y. It looks like an obscured Y, right? And occlusion starts right at the apex, at the center of our low pressure system. Why does it start at the apex? Because this is where we find the shortest distance between the two fronts, our cold front and our warm front. Now, when I closed the last video, I stated explicitly so that an occlusion stage can either be a cold front occlusion or it can be a warm front occlusion. Now, how are we going to identify if whether this is cold front occlusion or warm front occlusion? The key, it is in the position of our coldest air. These two diagrams here shows us those two different stages of the occlusion stage. This diagram that we have here shows us the cold front occlusion. And this diagram shows us the warm front occlusion. Now, if you look at these two cross sections, it is easier for you to be able to identify that this is the cold front occlusion and this is the warm front occlusion. How are you going to identify it on a synoptic weather chart if this is what they gave you? Now, our clue lies in these signs. These triangles, we said that they represent our cold front, and these semicircles, they represent our warm front. Now, if you go back on this portion of the system, you can see there is changes, interchanging shapes between triangle and semicircle. It shows you that there is a triangle, there's a semicircle, there's a triangle. A triangle represents cold front and a semicircle represents the warm front. But the last shape that is going to be right at the apex here will be telling us what kind of occlusion is depicted by this diagram. If it is a triangle right at the apex, this will be the cold front occlusion. But if it is a semicircle right at the center of the apex, if it is the semicircle right at the center of the apex. This will represent the warm front occlusion. Now let us pause a little bit and now, how do we identify a cold front occlusion and how do we explain a warm front occlusion? Now, when you look at these two diagrams, the only thing that changed here it is the position of the coldest air. Now, to explain what happens in cold front occlusion, you will be saying that firstly, the cold front catches up with the warm front. That is the first point that you need to state. You continue and then say the coldest air is found behind the cold front. As a result, the cold front moves faster than the warm front. It catches up with the warm front. Now, what happens when the cold air catches up with the warm air? The cold air starts to undercut the warm air. And once it undercuts the warm air, what happens to the warm air? The warm air is lifted gently along or above the cold air. The cold air starts to sink while the warm air starts to rise. Now, the warm air in the warm sector here will continue to rise higher and higher in the atmosphere until such a time that there is no warm air closer to the surface. And at that time, the cyclone now is ready to degenerate or to dissipate or to end. But the correct term that we use is that the cyclone dissipates. The cyclone dies out. The cyclone degenerates. In the occlusion stage, we do not, with capital letters, guys, we do not have cumulonimbus clouds. No cumulonimbus clouds. In the occlusion stage, there is no cumulonimbus clouds. What we have there is we have our light rainfall bearing clouds. This can be your nimbostratus cloud or it can be your altostratus clouds. Now, coming to this diagram here, you can see the interchange between the position of the cold air and the coldest air. In the warm front occlusion now, the position of the coldest air is now ahead of the warm front. It is very much important to note this. In a cross section of the mid-latitude cyclone, we have the warm sector between our two fronts and we have the cold sector behind the cold front, and the cold sector continues again in front of the warm front. So the temperature in front of the warm front is cold and behind the cold front is cold. Only then, only between our two fronts are we going to have warm air in the warm sector. Now, when that happens and we find that the air that is in front of the warm front, it is the one with the lowest temperature compared to the air behind the cold front. What is going to happen now? We are going to have the cold air from the cold front being lifted along the warm front. Because here, the coldest air in front of the warm front, it is now dense, it has more mass. As a result, it sinks and the cold air behind the cold front rises along the warm front. This air will continue to rise and rise and rise until such a time there is no warm air closer to the surface, and as a result, the cyclone is also going to dissipate. Now, when you're living along the coast, especially the west coast, you should always be in the lookout of these systems around winter. Because one moment you are in town, it's all sunny, and then the moment you know it, it's raining. Conditions associated with the mid-latitude cyclone. Now I'm going to try to use these two diagrams to explain how this occurs. Now this is our mid-latitude cyclone in its mature stage. We are going to use this diagram to try and explain what is actually happening in these two diagrams. This is when the cold front is approaching, and this is when the cold front passes over an area. The conditions are not the same. Now, when the system approaches the land, the west coast of this area, you look at this diagram, it means that the people over this area, they are now in the warm sector. They are now in the warm sector. And since they are located in the warm sector, the air that is found in the warm sector, it is warm air. So what will happen to the people along the west coast? These people, they are going to experience high temperatures. It is going to be warm over the land. But as the system continues to approach the land, the two air masses here, warm air rises gently along the warm front. And as a result, it starts to form scattered clouds, your nimbostratus or your altostratus clouds. Hence, the people of Cape Town, they may experience clear skies, or they may experience scattered clouds with showers, with light rainfall. When the cold front is still approaching. But what happens now when the cold front has now arrived over the land? How are the conditions going to change? We are going to look, because the cold air continues to move faster than the warm air. What's going to happen? This cold air is going to force the warm air to rise higher and higher in the atmosphere due to its steep pressure gradient. And once this air rises higher and higher in the atmosphere, this will lead to the giant cumulonimbus cloud to form. Now, within short period of time, from clear skies or scattered clouds, we start to see the sky changing now to overcast conditions. So the sky becomes cloudy due to the formation of the cumulonimbus cloud. Now, once the formation of clouds have occurred and condensation takes place, now these rain-bearing clouds will bring precipitation. But not just any precipitation. Heavy rainfall that may be accompanied with lightning and hail. So the people will also experience heavy rainfalls. Additionally, behind this steep pressure gradient of the cold front, we are having cold air that is fed from the cold Benguela current. So this cold air, once it starts to dominate over the land, remember that it is sinking and warm air, it is rising. As warm air continues to rise, it continues to feed the sky to continue to form those cumulonimbus clouds. But the cold air continues to sink and sink. So it starts to dominate the land. So what will happen to people along the west coast? They start to feel cold and temperatures start to drop. Temperatures starts to drop and it starts to become cold along the west coast. Now these conditions, your overcast conditions, your cold conditions, your heavy rainfall that may be thunderstorms accompanied with lightning and hail, will also be accompanied by strong winds, since this is a low pressure system and it brings unstable weather conditions. So the people are also going to experience gusty winds. By gusty winds, we are saying these winds will be strong. Now look at these two weather station models. Before the cold front arrives, the wind direction is facing in a northeasterly direction with a 20 knot speed. But once the cold front has now moved over the area, the wind speed is changing from northwesterly to southwesterly. And the wind speed has now increased to 40 knots. Now this change in air circulation When it occurs in the southern hemisphere, we call it baking. We call it baking. When there's a change in the circulation of air in the southern hemisphere, we call it baking. But when it occurs somewhere in the northern hemisphere, we call it veering. We call it veering. Now, when these conditions are occurring, you may agree with me. These conditions are either going to impact us negatively, or we can take some benefits from the heavy rainfall and some low temperatures that may be occurring. Now, let us try to discuss the impact of these conditions, either on us people as well as on the environment. Let us dive into it. Now, suppose that you are in an exam, you are coming across that 8 marks question. It's a paragraph question. You need to be very much aware of what they are actually asking you. Are they asking you to discuss the impact on the environment, or are they asking you to discuss the social impact from the mid-latitude cyclone? Now, when you discuss this on the environment refers to anything that is natural, that is not man-made, and social impact refers to the built environment as well as the impact that can happen on people or anything that belongs to people. Now let us go and discuss that. The impact of the cold front when it passes over an area, it brings heavy rainfalls, low temperatures, strong winds. All of those conditions combined are a recipe for disaster. Now we can have floods that may result, but floods may result from what? From heavy rainfalls. We can have soil erosion that occurs from where you can either say from storm winds, or you can say from heavy rainfalls. You can have eutrophication that is going to occur there, because once you have soil erosion, there are different materials that may be wiped from the land and all the way to our rivers. So that can try to cause pollution in our rivers. Strong winds can also lead to the trees to be uprooted. That is on the environment. Now let us see what will be the impact on people. Some strong winds have the capabilities of destroying infrastructure of people. And once the infrastructure has been destroyed, this may lead to a lot of insurance claims, which may try and affect the economy negatively. We are also having people that may lose their lives due to strong rainfall accompanied by lightning and hail, or only from strong wind. The positive side of things is that once we have more rainfall, then it means that there is more water available for use. This water may increase the volume of water in our rivers as well as in our dams. It can also lead to an agricultural activity to boom in over an area, especially now in Cape Town. They are more focused on the growing of crops, especially fruit. Now, once it rains heavily, then it means there's more water for irrigation. We can also have our tourists. Our tourism can increase. Where are we going to have our tourism increasing from? From the low temperatures that may be brought by the cold front. Once the temperatures are very low, it may result in the formation of snow, and this snow can attract a lot of people to the site, to tour the site, and this can boost the economy of the West Coast. Now, what are we supposed to do when we are confronted with such disasters? Firstly, you are supposed to stay indoors. Stay indoors, avoid windows as much as possible. To mitigate the flooding chances, we should have effective drainage systems in our areas. This will filter water away and prevent possible flooding. Along the coast, we can try to erect sandbags, which is also going to try to reduce the chances of flooding. You should make sure that you stock on enough food, your non-perishable food, your canned food, since they last longer. You should try, by all means, if possible, try to erect your buildings far away as possible from the low-lying areas, since low-lying areas are more prone to flooding. So please These are not just my strategies, but these are proven strategies that have proven to save lives and to save unnecessary costs. Please make sure that we implement them in your examination. And I trust and I promise you that you're going to make it. Otherwise, this is the end of our session today, and I'll see you in the next one.